Okay, we'll start our class if that's okay. Thank you everyone for being here. Unit AURTTD002 is servicing and inspecting steering systems. You know, when I did my apprenticeship that many moons ago, it was pretty basic stuff, mechanically run steering. No power assist steering, and today it's anything but simple now. We've got all this electronic gear that's part of our steering systems, that's also part of a lot of things in the car. We have, reverse parking, automatic parking mechanisms that are computer controlled that park cars with operating the steering. We have autonomous driving in some cases, or semi-autonomous, where you go to drift into another lane, the steering will shake, or the steering will pull you back into the lane so you don't cross over a lane unnecessary. All this is stuff that we now have to deal with that we didn't have to. We're also coming to a season where we could see fly-by-wire steering. You know what I mean by fly-by-wire? No, it means that it's totally electronic. There's no mechanical hookup to the steering box itself. It'll all be done through computer control actuators, just like your accelerator is when we don't have an accelerator cable. It's a bit risky because the steering at the moment, if something goes wrong electrically and you don't have any mechanical hookup to your steering, it could be quite scary on the road, couldn't it? So I don't think we're quite there yet. I do believe some of the Formula racing cars are using that technology. And I do know the likes of Nissan have brought out fly-by-wire, but they also have a mechanical backup to just back it up in case something goes wrong. I'm not 100% sure, but I did read somewhere where maybe a Lexus and a couple of other brands or BMWs or something have actually put in fly-by-wire. But I'm not sure if I'm right, but I did read something that made me think that that could be the case, but it's not normal at the moment. But yeah, I think it's something that we'll see in the future. So it can be very much, steering is very much a safety thing that we have to be conscious that we're playing with people's lives. If we don't do it right, okay, we're putting people's lives at risk, so we really do have to get it right. Add electronics to it, it's another dimension of stuff that we have to worry about and have to be sure about. So I think, we're in a world that's changing in the automotive industry where things are controlled by computers now, including our steering. Even our tyres are monitored by tyre pressure monitoring systems, so that if we have a lower than normal level tyre, it'll send out a warning to the dashboard. So everything is using electronics. And something that, we'll touch a bit on today, but there's a lot more to learn about it. Safety, we'll drum it in, and I feel like a recording when I keep recording these things, but if you think about it, if we're not doing things to make our workplace safe, we can have accidents, and accidents can put us out of work, accidents can make us debilitated. So we really do have to think about what we're doing, always using our correct PPE. When it comes to power steering, probably the most important PPE might be our safety glasses and possibly gloves. Why would I say that?
Chemicals.
Sorry? Chemicals. Yeah, what is power steering fluid? It's a hazardous material, isn't it? It's not good for our skin. Why would I want to put safety glasses on when I'm working on power steering?
The wind doesn't spill in your eyes.
Is power steering got a lot of pressure under a high pressure hose, which it does, so we don't want to undo a pipe and have it squirt in our eyes. Who's had oil in their eyes before? Yeah.
Brake fluid.
It's not nice, is it? Brake fluid you can wash out, I guess, because it dilutes in water, but it's still not nice.
Hard.
Yeah,
it hurts.
It stings, it does, that's right. Compressed air, I told you this many times. We don't want to be blowing up dust off the floor. Who's done that? Who's blown up the floor with the... like we've got these things that blow air, don't we, in our garden sheds where we blow all the leaves and that away. But compressed air has a lot more pressure than one of those blow-off things. But it is tempting to get the air compressor gun and start squirting and clean up the floor. I've seen people do it before. But what do we run the risk of happening if we do that? in your face, in your eyes. Yeah.
Skin.
Sorry? And also compressed air, if we blow ourselves off, if we get air penetrating our skin, it can get into our bloodstream and it can be deadly. So, you know, I've seen people plenty of times, probably done it myself in my younger days, blow yourself with the air, not realise the risk we were taking. So it's a risk that we're eliminating. It might be a low risk. I don't know if it's a low or high risk, but it's all worth the effort of trying to do that. Brake dust, again. Even though new brakes don't have asbestos in them, older cars could have asbestos, but we still don't know what the harm is when that dust gets blown off the brake drums. Should we use compressed air and we breathe that in? We don't know what harm that would do to us, so it's better we don't blow off brakes. What do we do instead of blowing off brakes?
Vacuum.
Vacuum, yes.
The liquid.
We can use brake clean, can't we?
Yeah.
So yeah, there's all those things we can do to protect ourselves. And I guess, vacuum cleaner is probably something that I never thought of using until I started teaching, and it makes sense, doesn't it? We can suck it up. And one of your questions, right? Everyone seemed to struggle. Some of your assessment questions can be worded to trick you. Okay? It looks like it's right. Put the right PPE on when you blow off the brakes. But when do we blow off the brakes?
Never.
Never. So that was a false answer, whereas some of you didn't realise. So yeah, just remember that. And what do we do about fluid spills? Do we leave them until we take the car out and clean it up? If I spill some oil on the floor?
Wipe it.
Sorry?
Wipe it as soon as possible.
As soon as possible? Not after I take the car out to give it to the customer who's waiting in my office? No, we do it straight away. Exactly. Makes sense, doesn't it?
Yeah.
Why do we do it straight away?
Slippage.
Slippage, exactly. We don't want to have a slip and a trip risk, okay? Anyway, I got a gearbox. Do we do that?
Yes.
Yes, we said yes. So yeah, we all know we bend our knees and we lift up straight, so we don't put the load on our back, okay? And we never work under a car without jack stands. Who's tempted to pull a wheel off without a jack stand when we're working on the car? I better say, who has done that before?
Everyone.
Everyone. Okay, but should we be doing that? Has anyone had a car fall? You have?
Rolled,
Sorry?
just roll on the jack.
You rolled on the jack?
Yeah, but I always put the spare, the tire which I take out, always under the car.
Do you know, I did the most silliest thing when I was young. I think I was an apprentice or just out of my time. It was a Valiant. And we put the transmission in and the selector wasn't lining up. And I needed the car to warm up so that it could get to the right temperature and I could dip the oil. So I left the car running, had a jack under it. I can't remember if I had a stand under it. I probably didn't, knowing me back then. And I went to adjust the selector so I could get in the middle while the car was running. Guess what happened? It went into reverse. And it took off while I was under the car on the jack. But the jack wheeled with it. I got out.
So you were selecting it manually?
I wasn't meaning to select it in manual. I was just trying to undo the lock nut to adjust the cable.
Oh, okay.
What a stupid thing I did. It wasn't even in park, I don't think. I think it might have been in neutral. So that taught me the hugest lesson. I can't remember the outcome, whether I damaged the car, probably did, but at least I got out of it. The worst thing could have happened was I could have got run over and killed.
Yeah.
So yeah, we need to be conscious. Should I have known better? Of course I should have. Of course I should have. Okay. Another thing happened to me when I was in my apprentice days. We had a car, I think it was a diesel, it was a ute, and I just hit the key to start the engine and it was in gear. And as I turned the car on, it started and reversed into my boss's car and crashed my boss's car. Do you think my boss was happy? He was not happy. So yeah, we need to think about safety, don't we? And when we're using the the car hoist, we make sure the vehicle's stable on it. We make sure that we use, or that the car is properly locked into place with the safety locks when we go under the car to work on it. And do we ever hop under the car while it's been moving up or down?
No.
No. Did I see someone do that here not long ago?
Yes.
Yeah, we won't go there, but we don't do that now, do we? Okay. All right, and we have to look after our environment. Why do we look after our environment? Any Isaac? Why do we want to look after our environment?
To avoid any hazardous incidents.
Sorry.
To avoid any hazardous incidents.
To avoid hazardous incidences, yes, that is correct. But why do we want to avoid them? What can we do to the environment if we do let hazardous materials go into the ground and soak into the ground? What will happen to that material? Any idea, Brian? Do you think it'll work its way into the waterways, into our creeks and into our oceans? Do you think the fish and marine life will benefit from that?
No.
It won't. Do you think we will benefit from it if it gets into our waterways?
No.
No. What about our children and our children's children? Do we want to leave this earth as clean as we can for them so that they can enjoy what we've enjoyed?
Yes.
So we do it for a lot of reasons. So environmental issues are very much in my heart because I want to see us look after our environment. So that's why we dispose of the liquids properly, our waste liquids such as oils. We make sure they go into a recyclable drum or tin or tank or whatever we use. We make sure that we maintain the right handling, that we store our chemicals properly, and we keep an eye on the containers we store them in, that they don't get old and rusty if they're tin containers and then leak out and get into the floor. We look after our hazardous materials in a safe manner. We have bunking around them so that we don't lose things if we did have an accidental leak, so it gets contained. So we do all that. And we want to watch out for noise. Why do we watch out for noise and air compressors and that? What can it do to us?
Damage our ears.
It damages our ears, so we want to look after our own self as well. Okay. All right, we can start now on steering. Now we've got all that safety and environmental stuff out of our road. Steering wheels are made up of mainly 3 items. Mainly. There's more, but mainly. Who can tell me those 3 items?
Steering box,
Steering box, yes.
Steering wheel.
tire rod
And
ends.
linkage.
So we could say a steering column is one item. You can cover the steering wheel in one item.
Steering rack.
We can say the steering gear, which is a steering box, is another item. What's the last item? Is our steering linkages or racks or whatever, okay? So 3 items are the main components of a steering. So this is a manual steering. Do you have manual steerings in Fiji?
Yeah.
We do?
Yep.
We don't see many now though here in Australia. Yeah, Bedford trucks. Who finds that the steering wheels are much bigger in a manual steering wheel car? They are, aren't they? Why would that be? Tractors, yeah. Why would we have a bigger steering wheel?
Easy to do. Less power needed.
Well, we've got more leverage if we've got a bigger steering wheel, and that's why, because we have to force that steering a bit more. We've introduced now power steering to most cars, and there's a typical rack and pinion steering. There's 2 types of steerings. There's a rack and pinion steering, and there's that steering box, as Alvin said, or a worm drive gear set, or a rack and pinion gear set, right? So there's 2 types of steering that we mainly come across. In the worm drive, we can have almost like a mechanical worm drive where it's just a mechanical gear against another gear to turn, or we can have what's called I've got to think of the name now, reciprocal bearing steering box. Reciprocal meaning that it runs off ball bearings. That actually is like a, I would call it like a nut, and the ball bearings are like the thread. The ball bearings goes through the shaft that's got like a thick thread on it. That as it traces the thread on the steering shaft, the ball nut will go around and circulate those balls and move up or down that rack to turn the steering backwards and forwards. And they have that type of steering to minimise friction. There's very little friction with the ball bearings compared to a gear type. So they're the type of steering gears, and we'll talk a lot about steering gears. When I talk about steering gears, we're really talking about the mechanism that steers the car, whether it be a steering box or a rack and pinion. They both run gears, okay? By the way, some of the names of these parts, our pulley for our front of our pump. This is a pump that pumps hydraulic fluid. The hydraulic fluid is what assists the steering, that allows the steering wheel to have a lot easier turning when we turn. So we have the pipes, we have the, they call this a power cylinder, I call it more of a rack cylinder, I guess. We have a control valve. Control valve controls which way the fluid goes. We'll look at that later. So we can have different configurations, okay? So we looked at the rack and pinion before. Now we're looking at the steering box. In this picture here, then we've got all these linkages going out to turn the wheel one way or the other. We get a bit more complicated because now we've got like a centre diff in the four-wheel drive setup here in the front with the steering going around the diff with different rods going at different angles. So we do get a bit more complicated with the way the mechanism is, but still a mechanism. He's looking a little bit more of how a steering box, a typical steering box with power steering assist would look. If we have a look here, we've got the thread there and the gear here, which moves backwards and forwards. In turn, moves what's called a pitman arm. A pitman arm is what swivels at the back, the bottom of the steering box, which is then connected to the linkages that go to the wheel. The fluid gets pumped in to whichever way this control valve wants it to pump to allow much more ease of turning that wheel because it assists the way we're turning the wheel. If we turn the other way, then the oil goes the other side of the piston that's in the steering box to make it easier to turn. You'll get a better comprehension of that as we move on, but yeah, basically that's the hydraulic system. Some people forget that this belt is a very critical part of the steering, the power steering belt. A lot of times now with more modern cars we have what's called a serpentine belt that runs everything, but earlier cars just have one single belt for the power steering, generally speaking, and that belt there, if it started to fray or slip, we could start to get our steering to become harder or not working as well, and often it's just a simple belt that needs replacing. Or we hear a squeak when we go to a full lock. We hear a squeak, and we hear a squeak on the full lock, probably because there's more pressure, or not probably, there is more pressure on the full lock, therefore that belt's got to work harder because there's more force for that pump to turn on a full lock, okay? And we hear that squeak, and that's why, because the belt needed tightening or replacing. Okay, another picture of the hydraulic system. You can see that piston? See the green forcing it one way, or the blue, so one way it would be going into the pump, the other way would be going out of the pump, so it would just depend on which way the steering wheel is going, okay? Most power steerings use our reservoir for topping up the fluid, that we keep the fluid in. We also have, now I mentioned earlier that we've got electronics now with our power steering. So this type of power steering is one type where they use a hydraulic motor. Rather than have your hydraulic pump running off the drive belt of the engine, right? They've sort of kept everything together in the rack and pinion, and they've put this reservoir and this electric motor, and it does away then with the actual pump. So I think you'll find hybrid cars particularly will have a system like this or a similar system because often the engine's cut off when it's on electric mode, but we still need to have power steering. So electric motor fixes that. But more and more cars, or nearly all cars now, are probably going to electric in one way or another. Electric motor does away with the loading of the engine. Every time we load up the engine when we use power steering, when the power steering pump is driving the hydraulics, we put load on that engine. We use more fuel. We take away some of the horsepower from that engine to run the power steering. So electric motors make sense the way we're going. With steering, we also have a tendency, when we are parking a car and we're not driving very fast, we have a tendency where we need more assistance. Because when we're driving, we don't need as much force because we actually have centrifugal force as we're turning the wheel. It's moving, it's rotating, we've got a little bit of speed. The actual force of the power steering doesn't need to be as strong. When we're driving down the highway, for example, and we're only moving the steering wheel a little bit. So with electric motors, it's much easier to control that because the electric motor, the computer can control by looking at the speed of the engine and looking at different circumstances. It can give you more assistance when you're reversing, for example, into a car park than when you're running down the highway. So that's something to think about as well for electric motors. Not all electric motors are in the rack and pinion.
A hydraulic power steering system employs a rotary valve interposed between the pinion driving the rack and the steering column. The rotary valve regulates the pressure distribution between the left and right halves of the hydraulic cylinder in which we've turned the steering rack. Pressure changes in both chambers generate a pressure differential that is converted into a force that generates the steering assistance required. The electric power steering employs an electric motor, generally mounted on a steering column, on the pinion driving the rack or, as in this case, on the rack itself. There is a torque sensor that is located immediately over the pinion. Its job is measuring the torque being exerted on the steering wheel by the driver. This torque is sent to the electronics of the power steering that are integrated within the electric engine that operates the steering. These circuits are embedded in a resin ceramic species protects from moisture and vibration. The torque values, as well as speed and info from the electronic stability program, are used to calculate the amount of assistance required. Motion is transmitted through a belt to a recirculating ball gear. Active steering was a technology introduced by BMW 5 Series in 2003. In the BMW system, by TRW, there is an epicyclical gear, operated by an electric engine through a helical gear. This electric motor allows adding or subtracting angles to the direction of rotation. At low speed, the electric motor supplements the rotation of the driver. In this mode, it behaves as a conventional steering response with only 2 turns lock-to-lock. At high speeds, the electric motor rotation slightly counteracts the driver's instructions. In this situation, the steering behaves as if almost 6 turns lock-to-lock, and the driver has a feeling of precision and stability. Other manufacturers like Lexus and Audi employ a more compact drive. Based on an engine of trains of elliptical waves. Despite its complex name, the operating principle is very simple. A motor rotates an elliptical ring gear, which engages inside a cylindrical pinion. The difference between the length of the perimeter of the ellipse and the circle makes. For every full rotation of outer ellipse, add or remove a little twist to the inner cylinder.
Alright, so there's a few different types of electric steering, as you've just seen. So I just sort of, sometimes they're on the steering column, sometimes they're on the rack and pinion, sometimes they're a hydraulic motor, not an electric motor. So yeah, you just get a bit of a broader perspective of what's out there. All right. Has anyone worked on an electric steering system? No one?
No.
No. No, I have done a little bit of work on electric steerings. I think it was a Barina, Holden Barina, had one on the steering column, and they were notorious for not feeling right and playing up. Just once
I did one calibration.
Calibration's important.
Yeah,
Yes.
I did one, but which was auto calibration. I just
Yes.
had to like punching on the.
But, yeah, I'm glad you brought that up because what Alvin's saying, there's a thing called a steering wheel sensor on cars that have electric steering. That steering wheel sensor needs to be calibrated every time we do something. For example, if we do a wheel alignment, we need to calibrate it. If we disconnect the battery, we need to calibrate it. Anything we do, particularly on the steering, we need to calibrate it. And a lot of people don't do that. I've had them where I had a Camry once that was always pulling one way, and it was only because someone had forgotten to calibrate the sensor. It's very easy to calibrate. It's just a matter of hooking up a scan tool, and you go in through a calibration system and just push, recalibrate. You have to have the steering wheel in Australia position to do it. But yeah, that's very important. So, excuse me, types and applications of lubricants and hydraulic fluids. So we always want to check the manufacturer's recommendation. There was a time where nearly every power steering system had what's called automatic transmission fluid in it. And we would get away with that, but not today. Not today, because there's specified needs for those newer cars with their power steering systems. We put the wrong oil in and we get into all sorts of trouble, possibly with the steering, okay? So always look at manufacturers' specifications. And all steering systems contain oil, so even the older systems that were manual steering, they still had oil in them for lubrication reasons. But most cars now with power steering, the oil is for more than just lubrication, but it is there for lubrication, but it's there for hydraulic abilities to be able to apply the steering to turn and assist the steering in one way or the other. Okay, so some machinery, I've never worked on tractors really, but some tractors or some machinery, they do not have a steering mechanical hookup. It's done by hydraulic fluid. So it's a purely hydraulic system where the hydraulic force will force the steering to go left or right, okay? Also, I had a boat that had hydraulic steering, so I know the principle on that boat where we had a ram and the ram would work off the hydraulic pressure. So in a way it's connected hydraulically. So as we know, any liquid cannot be compressed, so it'll be a force, it'll move. So in a way it's quite safe. I hope I cover this. Oh yeah, when we're inspecting the steering system, we're looking at things such as the fluid level in the hydraulic system. We're looking for fluid leaks. We want to check all the linkages for damage, such as tie rod ends, centre link ends, pitman arms, idler arms, rack and pinion bushes in the rack and pinion itself. Anything that could wear we're looking at. And we're going to look at some of that tomorrow in our practical class, how we check things. We don't have too much free play in the steering wheel. Free play is a bit of a pain if you're driving down the road because there's something worn for that to be like that. So we're going to be checking things like that. Checking for the mounts. A lot of times in the rack and pinion, those rubber mounts that hold and support on those brackets that support the rack and pinion can become worn and get sloppy. And it can be a funny feeling when you're driving. You get this funny feeling in the steering wheel where there's almost movement, but nothing happens because of the rack being, it's moving physically and it's not secure properly. So we want to check those bushings. We mentioned earlier about the drive belt, making sure the drive belts are sound and good. Checking all the, any looseness in any of the steering pivot points, such as pitman arms, idle arms, and upper and lower ball joints. The other thing with ball joints, I've seen a couple of things where they get stuck because they get jammed up with gunk or rust or whatever, and they cause a tightness in the steering. And sometimes you can go down the path of thinking it's a power steering problem when it's really a mechanical problem. So we need to be aware of things like that. I've also had squeaks in suspension, being a ball joint, but there's no movement in it. You can't see anything wrong with it. So yeah, there's a few things that we can diagnose and we need to be aware of when we're looking at suspension. Okay, and we're looking for any sort of damage that could be there. Who knows what that is? Someone say? Kingpin. You know, you're the king. How did you know that? Because you work on trucks. Correct?
It's a front axle.
It's a front axle.
Front beam was it?
There's no ball joint. They use a pin. When I was doing my apprenticeship, it was common to have kingpin suspension in not normal cars back in the 60s. And they would wear, and you get a lot of wobble in them. And what we'd do, we would put a new pin in, but we'd also put new bushes in. We'd press the bushes in, and then we'd have to ream those bushes so that the pin would go in nice and easy, but not loose. And so we had to do those sort of jobs. But now we don't see kingpins in passenger cars, but we still see them in some trucks. Is that correct? Probably more so now with ball joints, but some trucks still use them. One of the most common steering systems now in the light vehicles are what we call the power assist rack and pinion. Not including four-wheel drives, but even some four-wheel drives are using rack and pinions. But rack and pinions are probably what you're going to see 90% of the time now, if not more. So we need to be familiar with the rack and pinion. Can you see that cylinder? This is a good idea of seeing how the hydraulics work on the power steering. Can we see that there's an arrow pointing there? So when we get some hydraulic fluid behind that piston, if we're turning the steering wheel to the left, that's going to assist for the rack to push out. And that's how the power steering works. But if we turn the steering wheel the other way, it's going to go the opposite. Do you know how that happens?
Yeah.
How?
Because of that rack piston, the one in the middle has got the seal.
Which one?
In the
Yes.
And then which breaks in the middle once it pushes, so this push that
That's
side,
correct.
and then the opposite way.
That's correct.
So the valves will open
The valves?
opposite.
What valves?
Pressure valves to the release, because once it goes,
There is a relief valve in the power steering system that allows, if it gets excessive pressure, to release that pressure so we don't blow the what we call the power steering hoses, right? The braided hoses, we don't want to be blowing them. But my question is, there's two pipes, 1, 2. So obviously one pipe will allow pressure, while the other pipe will exhaust the fluid on the other side, and then vice versa. So when I turn left, it helps me on my left turn. So how does it know I'm going to turn right when I turn right to go on the next turn?
because of that steering, what's called that rack.
Are we talking here?
Yeah,
Yep.
yeah. That one has got that valve in there which opens and closes once you move this side or the other
Yeah,
side.
you're on the right track.
Yeah.
There's like a torsion rod, and it twists and has this twisting in it, right? And as it twists, it will actually move a component that's inside that valve body. It'll move a component to cut off an orifice hole to allow fluid to come through this pipe, but open one to go through this pipe. And then when you turn the other way, it works the other way around. So you'll see that in the video that we'll play later. But yeah, it's quite genius that they've designed it that way.
Is it like a rocker?
More, not so much a rocker, but more, it's a sleeve, and a sleeve twist, okay? So when there's a bit of torque, you have to have a little bit of torque. When it's in a straight ahead position, it stays in the middle, and there's very little power steering fluid on either side of that. But as you torque and you turn, it will turn that sleeve one way and allow the fluid to go one way. And when you turn it the other way, it's the opposite. So it cuts off and opens. Okay.
I haven't actually like opened and seen inside those ones.
Yeah, I get the evil eye from Isaac. I get in the evil eye, don't I? All right. Alright, here's the video, this might tell us.
When the steering is turned, a rotary valve integral to the steering input shaft directs fluid to one side or the other of a piston attached to the steering gear. Pressure then increases as required to provide assistance. In a Wurman roller steering box, the piston slides in a cylinder in the casing. It has an extension formed on one side, with teeth which engage teeth on the pitman shaft. Pressure applied to either side of the piston produces a force, which is transferred through the teeth to help turn the pitman shaft. In a rack and pinion steering gear, the piston is formed centrally on the steering rack, and the rack housing provides the working cylinder. Seals at each end of the cylinder isolate the power section from the rack and the helical pinion. Seals in the rotary valve section of the pinion input prevent fluid leakage there. Connecting pipes transfer fluid from the rotary valve housing to one side of the piston or the other to provide assistance which acts directly on the rack. The rotary valve is located between the steering gear input shaft and the pinion gear. It consists of an inner member which forms part of the input shaft and a surrounding sleeve member fixed to the pinion gear. Turning the steering wheels makes both members rotate in the steering gear housing, but it is the slight relative rotary displacement of the inner member and the sleeve member which controls and directs the power steering fluid flow. This slight rotary displacement is allowed by a torsion bar, which is connected to the pinion gear at its bottom end and the input shaft at its top end. When the steering wheel is turned, there is resistance from the front wheels of the road surface. This resistance is transmitted through the rack to the pinion gear so that the input shaft twists slightly on the torsion bar. Since the inner member is also attached to the input shaft, this twisting provides a relative rotary displacement of the inner and outer members. It is this displacement that lets fluid flow through the valve to act on the piston at the steering gear. The input shaft can twist through only a small angle before it contacts a stop on the pinion gear. This is needed to provide manual steering when power assistance is not available. With the engine running and the steering in the neutral position, fluid flow is directed into the valve assembly through drilled holes in the outer sleeve. As soon as the steering is turned to the left or right, the slight relative movement occurs between the inner and outer members. In the neutral position, the inner member lets fluid pass equally to both sides of the rack piston and return to the fluid reservoir. Equal pressure is applied to both sides of the rack piston. No power assistance is needed. When the steering is turned, fluid is restricted from making a free return to the reservoir. It is now directed to the side that matches the turning action. At the same time, fluid on the opposite side is directed to the return circuit, back to the reservoir. Slight rotation of the valve gives a small amount of assistance, which becomes progressively greater as the torsion bar flexes and more assistance is needed. The grooves of the inner member are precisely shaped to meter the flow of fluid.
Okay, that probably gives you a bit more visual understanding of the way that valve works. Any questions about that? Is everyone following? Okay. Okay, so when we service our steering, sometimes we need to flush out the fluid, don't we, to get the old fluid out? Some manufacturers will recommend us to do this. A lot of them don't, but there's telltale signs. The oil gets a bit dark, it smells a bit. You know, it makes a big difference if we service that and get rid of that old oil and put new oil in and freshen it up. It does prolong and maintain that steering system to last longer. The oil gets very much contaminated with heat. It changes its properties and contaminated with just wear and tear that's broken up inside the steering through normal wear. So when we flush a system, we can suck out the oil and put new oil in, but that's only half flushing it out. We've still got half the fluid still in the system. So the best way probably is to block off the return where the oil returns back into the reservoir. Block that off so that we can keep filling up the reservoir. We can turn the pipe that would normally return to the reservoir into a catch can, start the car up. As long as we keep pumping new oil into that reservoir while we're seeing that old oil run out, we can flush out until we get clean oil coming out. It's quite easy to do that. When I say easy, I guess it depends on the accessibility of everything. Some power steering units can be tucked away down in a very awkward spot, but in a lot of cases it's not too bad. We'll probably do that on my Camry maybe tomorrow, we'll see. All right. We don't want to let that oil run out of the empty on that reservoir, okay? If we've got air in the power steering system, if we get a gutful of air in it, it will cause a whirring sound. We get a whirring sound in the pump, and it's trying to compress air that way, and it's not compressing, not that it can compress the hydraulic fluid, because it can't, but it can compress the air and causes this whizzing sound. So if we ever hear a noise in a power steering, it could be low on fluid, and it's got air in the system. So it's just something to think about as well. Okay, we do call things differently, okay, in our industry. It's very frustrating. I was talking to Vinish before. I call this a drag link. Some people call this a center link. Some people call it a relay link. Some people call it another name that I can't think of now, but there's all these different terminologies for the same thing. So it can get confusing. I think America call it a center linkage, which makes sense, it's in the center. Why do we call it a drag link, I'll never know, but that's what I grew up to call it. I think our book I know the other name, our book calls it a track rod. I saw that before, a track rod. So anyhow, it's what it is. If we remember a terminology that we know, that's the main thing, and I think drag link I'll use mostly because that's what I learned to call that. So we have a drag link. We call these things tie rods. What goes on the end of the tie rods are what we call tie rod ends. I call the inner tie rod end inner tie rod, and the outer one, which is near the wheel, the outer tie rod. So these are terminologies that I think are normal. See these here? They're a sleeve where the tie rod screws in. Excuse me. Finish. The tie rod has a sleeve, okay, and the tie rod screws in. That's one type. And that type, when you want to adjust the toe in, what do I mean by toe in? Toe in is the way the wheels are facing when you're going straight ahead. If we want the car to toe in a little bit, we adjust it so that we kick the wheels in. I'll exaggerate. If we want it to toe out, we go that way. Why do we want to do that? Sometimes, okay, when we go around a corner, we want the outer wheel to turn less degrees than the inner wheel. The inner wheel is going to take a much tighter turn. If we have the toe in a little bit like that, when the car's turning, isn't this wheel on this side going to turn in more than this one because we're towing in a little bit? Does that make sense? Can we imagine what I'm saying?
Yeah.
If we do that, we're going to get less scrapping. Is that the word? I'll probably have a bad scrapping. I think that's the word. We're going to get less scruffing on that tyre tread and less tyre wear. So that's why we change the angle a little bit. It helps with tyre wear, okay?
Just a quick
Yes.
question. Well, once you do the toe in, right?
Yes.
Well, it's not going to wear your tire quicker than if it's going to be parallel.
If we had a good question.
Yeah.
If we had the wheels going straight like that,
Yeah.
okay, we're getting less resistance on those tyres, and it's going to give us better performance, and it does.
Yeah.
If we tow them in a little bit, yeah, it's going to marginally give us a resistance more. If we tow it in a lot, it's going to give us a heck of a lot of resistance and a lot more tyre wear, okay? But we have to have we have to look at an overall scheme of things. So we have to have a look. Is the car doing a lot of turning? In the city, yes. So we need to set it up. We have a term called tow in and tow out on turns. Tow out on turns and towing on turns. And that angle is critical, and it's governed by everything being in good condition in the steering, having a good straight, nothing bent in the steering, and then having a slight bit of tow in. But some manufacturers tow out a little bit too, particularly front wheel drive cars, because when you're driving on a front wheel drive car, you're accelerating and driving on those front wheels. It has a natural tendency to tow in. That's why we tow them out a little bit. So yeah, manufacturers have worked it out, and it's, I suppose, complicated, but not so complicated, you know. It sounds complicated, but in theory, and you start to understand geometry, steering geometry, it does start to make sense, hopefully. And the main reason we have wheel alignments and the geometry set up is to give us the best possible steering we can get, as well as the least amount of tyre wear that we can experience. We always get some tyre wear. Alright, so I started off talking about those sleeves. Those sleeves turn to adjust the tow in or tow out, depending which way you want to go, to get the alignment right. That particular sleeve, I used to have a tool to hook into, because there's a split in the actual tube itself, and I'd get a tool that lift into that split and pull it and turn it around to adjust it. Sometimes they get a bit rusty. You put some CRC on it. They have these clamps on the outside to clamp it down. Ford Falcons were big for using that style of them. But other types just use a barrel with a lock nut, and you have a thread, and that's probably like Toyotas and many other cars where they have a big lock nut you loosen up, and then you can actually turn. Once you've undone the lock nut, there's a lock nut on both sides, the inner and the outer. Or if it's a rack and pinion, which mostly are, there's only then one lock nut, and then you just turn the shaft and it adjusts that way. All right. So yeah, here's a typical tie rod end where you actually turn the shaft. You spin that shaft when you loosen that lock nut there to adjust the toe in. What this person's doing is looking for movement in the tie rod end. How much movement do we want to see in the tie rod end before we condemn it?
0.3.
Any other suggestions?
Almost nothing.
Almost nothing. I'd say go one step further and say nothing. We don't want any movement in a tie rod end. There is an acceptable amount of movement we're allowed in a ball joint. A ball joint, even though we call this a tie rod end, typically that is a ball joint. But for whatever reasons, they say we don't want any movement in a tie rod end. But in a ball joint, sometimes we can have a little bit of up and down movement that's acceptable, but we'd have to look up the manufacturer specifications to make sure it was within those specifications, okay? But in a tie rod end, no movement at all. If that boot is damaged, what do you think we should do? Change what?
If you can get the boot, change the boot, or just change the tire.
I would say change the tie rod end.
Yeah.
There's a time when people would mess around with boots, but if that boot's been damaged, there's a good high risk. There's contamination that's got into that joint, because that boot seals it up so it doesn't get contaminated. So just the price of a tie rod end is cheaper than the safety of the risk of someone having a problem because they've neglected to change a part that could be contaminated and eventually wear out. All right, and it can wear out in different ways. It could get the grind and grit inside it and become stiff, and that could cause hard steering one way or both ways. So there's a lot of reasons why. Just replace it. Okay, who's seen a shock absorber on the steering? Yeah.
Four wheels.
Why do we have a shock absorber on the steering wheel? No idea.
Hard to absorb the hard hit.
It's to absorb vibration.
Yeah.
Okay, so we get a little bit of a shimmy or something in the steering wheel to stop that sort of stuff. So most of them are non-adjustable. They're once they start to leak or they get weak, it's just replace it. It's pretty much like a shock absorber. Okay, what do I mean by dry park check? This is an American expression, by the way. I've never heard of it before I read this in preparing for today. Dry park check. No, I don't blame you if you don't know. But what I would do, if I wanted to check underneath the car for the suspension, I would have it on the ground, the whole weight of the car on the ground, the front wheels on the cement. Someone's to shake the steering wheel, okay? While that person's shaking the steering wheel just a little bit each way, I'm under there with a torch looking at each of the joints. If I see any movement in any of those joints, it will normally pick it up because there's load on those joints. So we're loading up the suspension steering components to see if there's movement in them. And we're just doing that on the ground. Quite an easy, quick test, but very effective test. And we'll do that tomorrow, okay? So to performed with the full weight of the vehicle, have an assistant to rock the wheels backwards and forwards, check for looseness in the idler arm, center link, tie rods and pitman arm, so anything that can have movement, even the rack and pinion if it's a rack and pinion. Who's ever done something like this? Put a weight, a scale to measure the tension of the steering wheel. Anyone?
No.
Has anyone ever felt the steering wheel a little bit stiff when you turn the steering wheel on some cars?
Yeah,
When they shouldn't be stiff?
Yes.
Yeah. So they've gone to the extent of putting a scale on it to see the weight of and looking for the weight on one way and the other way. I don't really see the necessity of doing that, but what I do see is common sense. If we feel something stiff, if a hydraulic power steering, rack and pinion steering is really hard to turn this way, but not hard to turn this way, what do you think that would probably indicate?
The blockage in the valve or something could be in the holes, the drilled holes or something.
There's something going on with the actual rack itself. It won't
Could be a leak.
It won't be the pump, will it? Will it
No.
be the pump?
Now could be the leak in the.
It could be an internal leak on one side, all that, yeah. What happens? Next time I'm putting up the front finish, a warning.
I was telling him on that topic.
All right, maybe I'm being a bit too anal here, sorry. But all right. Now, if we had hard steering this way, hard steering that way, what do you think about that? What could that be? Pump, it could be the pump. It may not be, but it could be
Loose
the
belt.
pump. Sorry?
Loose belt.
Loose belt, could be, loose belt, yeah. So it's a common thing. It could be the rack, but more unlikely to be the rack.
Or the most common thing I found out, wrong oil.
Yeah, wrong oil, yes. Yeah.
Which one might be, steering.
I talked earlier about manufacturer's oil. Make sure you put the right oil in, okay? All right. Also, a tight ball joint can cause hard steering. Just don't rule that out either. How do we go over time? 10 minutes, okay. Okay, a tie rod articulation effort. So what that means is, how free is that ball to move around, okay? Is it stiff to move around? The only way we're going to know that is if we unhook the ball joint. Not ball joint, tie rod end, okay? And then we can feel it manually.
It should have a bit of drag in it, right?
A little bit firmness, but an even firmness, but not, it's got to be, fair. That tie rod end, they're fairly inexpensive, but there's some really cheap and nasty ones out there that they're selling online on eBay and whatnot. I don't think I'd be confident in putting a non-brand name steering part on my car. I think I would like to be sure of and have some confidence of what I'm putting in my car that was, when it comes to safety things, some things it doesn't matter, but when it comes to safety things like steering and brakes, I'm very fussy about that. So it's up to you, but yeah, I would be playing Russian roulette, I think, if I put a Chinese cheap eBay part in steering. We're talking about pitman arm, or idler arm, idler arm. Do you know what I mean by idler arm? Anyone doesn't know what an idler arm is? Be honest. What's an idler arm? If I ask someone, will they tell me? Joseph? What's an idler arm?
No, I don't have.
So you didn't be honest. You've got to tell me if you don't know. I want to know if you don't know so I can go into it for you. When we have a steering box, not a rack and pinion, when we have a steering box, okay, we have the what's called a pitman arm. I mentioned that before. A pitman arm is the part that bolts underneath the steering box. It's the part that moves as the steering turns, okay? So we then have a drag link. I call it a drag link, but it can be a center link or a track rod, but we have this drag link that runs from the pitman arm to another pivot point. Okay, so when the steering wheel moves, this drag link can go backwards and forwards, okay? Moves with the steering wheel. And it pivots off what's called an idler arm. An idler arm is just a pivot point. It's idle, but it's there to move as the steering wheel turns. And an idle arm can be bolted to the chassis of the car, right? It can be look like a pitman arm. It looks like a pitman arm, but it is free to turn. It's free to twist with the drag link, okay? And that idler arm, it needs to be nice and firm. It also needs to be parallel. Can you remember this? It needs to be parallel to the pitman arm. It needs to be in balance. It needs to be even. There will be a question on your assessment about being parallel. Okay? An idle arm has to be parallel with the pitman arm. Do we understand what a pitman arm is? The pitman arm looks like this, but it bolts onto the steering box. And it's what it twists. It just twists like that, backwards and forwards. So as the steering wheel turns, there's a gear reduction from the steering wheel to the steering box to your pitman arm. You'll turn the steering wheel a lot more than what that pitman arm will turn because of the gear. Okay? We have a gear to allow us to have a leverage advantage. We might turn the steering wheel, we might turn 2.5 turns, which would be 900 degrees. We turn the steering wheel 900 degrees to get a full steering wheel revolution from one lock to the other. Okay? But we're only moving maybe 60 degrees of the wheel, where we're moving 900 degrees of the steering wheel. Does that make sense? So we're turning the steering wheel a lot with only a little bit of movement at the what we call pitman arm. That pitman arm will move a little bit, and it will allow the rod, the tracking rod if you want to call it that, I call it a drag link. That drag link will move a little bit, not a lot. But whatever it moves by the pitman arm, it's offset by the idle arm, because it moves that much as well. But the idle arm's not been driven, whereas the pitman arm's been driven from the steering box, okay? On the drag link, there's 2 other rods on each side, which connect to the wheel. They're called the tie rod. The tie rod and the tie rod ends. And that's how the steering moves. When we talk about rack and pinion steering, guess what? There's no idler arm. There's no pitman arm. The steering box is not like the conventional steering box that I'm talking about. It's a rack now. So the rack does away with a lot of parts, which is a much better system, less weight, less manufacturing cost, more direct, and yeah, a whole lot better. That's why most cars now use rack and pinion steering.
And we use less joints.
Less
We
joints.
only use 2 at the end.
Yeah, less moving parts.
The outer ones.
Exactly. But 4-wheel drives, a lot of them still use this system. Not all, but a lot of them do. Okay. So what this picture's showing us is we've got to check that there's not excessive movement in that idler arm. The same goes with the pitman arm. We don't want excessive movement in that, because any movement in those linkages will represent free play in the steering wheel that we don't want. Plus, over time, wear and tear can cause a catastrophic disaster where we lose steering if something was to pop off because of neglect and we haven't done our job by inspecting that car properly. Okay, so the rack and pinion steering has only 4 wear points. The tie rod ends, and we check the power units for power steering fluid leaks, and we inspect the amounts, the tie rods, the bellows. What's a bellow? Who knows what a bellow is? Yeah. No, call that a bellow, okay?
Oh.
So we want to check the bellows.
Like a boot.
It's a boot, that's what it is, a steering boot. And we check the steering couplings on our steering column and the steering rack for adjustments. What adjustments are on a steering rack? For that matter, what adjustments are on the steering box? There are adjustments, and we'll cover that soon. But there are adjustments, and we'll talk about that more. I very rarely have ever adjusted a rack and steering. You have? Yeah. But I very rarely need to, But there are times when you do have to, okay? All right, I'm going to stop for morning tea now, unless there's some questions. Any questions?